Hi guys, it's me Ubprogrammer and welcome to the Pytorch series, and the topic for today is multi-layer neural network. So in the multi-layer neural network we have hidden layers. So this concept is really important in the neural network as a whole. So we will talk about that in this lecture, and we create these hidden layers to give the ability to our model to understand the correlations and patterns which are included in our data, right? So this is the main you can say backbone of the neural network, which we will talk about in detail today, right? So let's see how these hidden layer works. So you have the inputs, right? So x1, x2, x3 and so on. There can be many inputs, and think of them as for the house prediction system. Let's say you have x1 is equal to number of bedrooms, x2 is equal to number of bathrooms, x3 is equal to it is uh, the square foot area, right, of your house, and then y, which we will calculate as the output of this MNN or the multi-layer neural network will be the price, right? So we have the inputs, and then we for creating these hidden layers, what we will do is create two different vectors of weights for this input. So see, in the uh, simple layer neural network, what we have is only one set of weights, so w1, w2, w3, and that's all, right? So a single neuron is looking like this. But in the multi-layer, it's kind of look like this. So we have one set of input, but for the two neurons in an hidden layer we have two sets of weights, so that means six weights for three input, right? And so this w1, w2, w3 is connecting this vector of input to this neuron in the hidden layer as the first neuron, and then the second neuron has its own weights which are connecting from this vector of inputs, which are w11, w12, w13. So 11, 12, 13 is the weights for h2. H2 is the neuron in the hidden layer, and then h1 has w1, w2, w3. So this is the main concepts of the hidden layer, right? So I have added this recall here so that you can understand in the simple neural network, or it is not a network, actually it is just a simple neuron. We have only one set of weight, right? But in this we have multiple sets of weights, and these weights will be updated as time by time. We will talk about in the backpropagation and things like that. Okay, so now these two input, these two weights can be represented as a matrices containing two columns, one for each weights, right? And this is the output of this MNN. Now let's talk about in the real coding, right? Because we want to code it ourselves. And so you can see we are just importing the torch, defining our activation function, which we will add in every output, right, of layer. So we have our features. As always, we have our features. We have 5 features. So in the diagram, if you see, we have 3 features, but there can be a number of features, right? So we have there 5 inputs to our neural network, and I have added these comments for you to understand. So if you don't understand in the first go, just tear down the code and you will get it, right? So we got the inputs, then we have the weights. And what are these weights? So I have named this variable weights from input to hidden layer. So that means this input layer to hidden layer, these weights, and how many weights should be there, and you can just now calculate it. As we have 5 features in our network and two we want the 2 neurons in our hidden layer, so we have to get 10 weights. So that's why we have these 5 and 5 10 values. And I have obviously written down here. So we want 2 neurons in our hidden layer, so that's why we have, let me just, we have 10 weights, 5 for each, right? So this is the weights, and then we have to reshape this weights. And why we want to reshape it? Because we want to satisfy the condition of matrix multiplication, which is number of column of first tensor should be equal to number of column of number of rows of second tensor. So this have a shape of 1 row and 5 column, this input vector. And so our but in the weights we want this to 5 rows and 2 columns, right? So that's why we have reshaped our weights so that we can do the matrix multiplication as we want. And then we have the bias of this hidden layer. So bias is the term we add in the output of any layer, right? So it is also being updated by the backpropagation or gradient descent, the optimization algorithm, which we will talk about later. But it will be the term, and you can think of it as also the weights. If the weights will be updated, this term will also be updated, right? And then these are the weights to be added in the output of hidden layer. And this number of bias, so how many bias should be there, it should be equal to the number of neurons or output of the hidden layers. So in our case it's 2. We want 2 neurons or 2 outputs in our hidden layer, so we have 2 bias to be added in them, right? And then we are calculating our output for the hidden layers. This is not the actual output of our model, this is the output of hidden layer. What is that? The hidden layer output is the, as we always do, the sigmoid activation, or you can use any activation, ReLU activation or 10H, right? But we have our this sigmoid activation, a little function here just to keep things simpler, right? Then we will do the matrix multiplication of what? The inputs and the weights of this hidden layer, right? Then we add the obviously the bias. Now if we just copy this code and I just execute it, so we have understood this. And let me just show you the output. And as you have already guessed, this output will be 2 neurons, or the 2 values, you can just simply say that. If I just run it, so you can see I am getting 2 values, right? And so now the main things of hidden layer start. These 2 values will be acting as the input for the our output layer. How is that done? I know it's kind of confusing, but bear with me, you will understand this. So we have seen this, and now we are creating the weights of the output layer, or the you can say weights for hidden to output layer, right? And let me just show you graphic. So this is the hidden layer and this is the output. So what we will do is we will create weights for these. So these strings kind of have weights in them. And let me just, yeah, So how many weights should be there? You can just calculate as we did before for them, right? So as we want one output in and the output layer, so our actual output will be one, let's say price of the house, right? So that's why we have two weights, because uh, we have two neurons in our input layer, which is now the uh, hidden layer, output of the hidden layer, right? So one for each to the neurons of hidden layer, which are now acting as input for the output layer, right? So this is the new concepts, I guess. And then we have the bias. So for now we will only have one bias because we have only one output. And then the calculating output, this is really simple. The activation, then we have matrix multiplication of this hidden layer, and this weights we have just use view here to reshape it for the satisfying the condition for matrix multiplication as we did before. Then we are just showing our final output. So this is the main concept of the hidden layer, and we will use the NN module for from Pytorch in the very next video. But the main key concepts to take from this video is that if we have two hidden layers, then the input of second hidden layer will be the output of first hidden layer. So this is the main concepts. Now I will just show you by drawing this whole network so that you can concrete these ideas, right? So solidifying these concepts. So let's grab a pen and do that. So if I just, yeah, so what we have is 5 inputs, right? 1 2 3 4 5. So these are the x1 and so on x5. We have 5 inputs here, and then we have two neurons in the hidden layer. We have one hidden layer, right? And then connecting to that, and then connecting to this, right? These are the 10 weights, you can calculate them. Then we have final output, which is this final output is this one. These weights are, all of these weights are these weights, right? 10 weights. These two what you can say, the neurons of hidden layer are just these output, right? So it's kind of messed up, but try to keep things sequential, like linear in the scale, right? And you will get it. And inputs are the inputs. And what are these two strings? These two strings have weights, which are weights for hidden to output, these two values, right? So this is the whole concepts, and if you can't just understand it or grab it at the first go, it's all right. You can just reach out to me on the WhatsApp, or mail me, or comment it down below, right? Thanks for watching. I will meet you in the very next video.